We're now shifting to session 2, which is enhancing information through tools and partnership. During this session, you'll hear from DWR experts sharing innovative tools, data platforms, and monitoring approaches that are helping advance water management across California. So these are going to be fast-paced 5-minute lightning talks, so just a heads up there. So it should be fun. So this is just a quick lineup of all of our session 2 speakers. With that, I can hand it over to our first speaker, who's Jamie Anderson. All right, over to you, Jamie.
Hello. Okay. Hello, is that better? Okay. I'm going to be talking about the state's climate change assessments, and DWR has been involved in all of them. The assessments fund targeted research to create actionable science that we can use in our decision making. So in 1989, 15 years before we had official climate change assessments, Maury Roos, our chief hydrologist, was involved in the first unofficial state climate assessment looking at the impacts of global warming on California. And the metrics that he presented there, looking at things like a reduction in snowpack and spring runoff, we still use today. In 2006, the first official climate change assessment came out, and DWR was the only state agency that provided original research. And so we contributed an approximately 250-page report to that assessment, and that work got a lot of attention, and that came out in a journal article. And then the lead for that project, Francis Chung, was invited to the United Nations in Switzerland to present the work because they were very interested to see how people, in practice were using science. So for the second climate change assessment in 2009, we updated that analysis with a much smaller report. We made a one-page summary, and we really targeted metrics that are used in decision-making, like delta exports, carryover storage, things like that. For the third climate change assessment, we were in a budget crisis. So it was a much scaled back effort, but DWR's executive for climate change, John Andrew, he was involved in the steering committee and review of that assessment. Then in 2008, we were in better budget times, and so the assessment really grew in its scope, and DWR's participation grew as well. So the assessment added regional reports and topical reports on oceans and environmental justice. And then DWR, one of our main contributions was based on a partnership that we had. We had convened a climate change technical advisory group to look at all of the available global climate models and give us advice on which ones to use for water resources impact assessment. And so they recommended 10 global climate models, and the state assessment adopted all of those recommendations for the state assessment. So that was an example of a partnership that we had that then benefited others beyond just the initial purpose of that work. And then we contributed several original research papers to that assessment on climate risks, water levels in the Delta under climate change, drought risks to small systems, and several others. And we provided a lot of management support for that assessment, and we were involved in the peer review, and all of our targeted research that we submitted was peer reviewed with the same process. We are currently in the 5th climate change assessment, which will come out in summer of 2026. And so this assessment is the first one mandated by the legislature, which brought with it funding and full-time staff, which is awesome. So this is a much more inclusive effort now, and they've expanded and invited state-led reports from, I think there's 6 or 7 agencies providing reports. Ours is on collaborating for climate resilience, the power of science and partnerships. We have a lot of people working on putting that report together. It is targeted around it's organized around our strategic goals and providing, on-the-ground examples of the ways that we are building this climate resilience and using science to support our decision-making and the benefits of our partnerships, throughout the department and the different activities that we are doing. So look for that in June of 2026, and I made it in 4 minutes and 15 seconds.
Thank you, Jamie. All right, our next speaker is Lindsay Correa. Over to you, Lindsay.
All right. Good morning. I'm excited to share with you DWR's Science and Technology Partnerships Inventory. This presentation was developed with lead scientist Dr. Luis Conrad and is part of a larger strategic plan initiative to promote science partnerships and co-production of research. DWR, as a science-driven organization, relies on its diverse partnerships to advance research and innovation across water management sectors. We're a multi-decadal organization and have long-standing partnerships that have informed water management operations over time, such as the research and operations partnerships you've heard about with the Center for Western Weather and Water Extremes at UC San Diego and Scripps. We're also growing our partnerships as our organization has really grown in scope with relatively newer areas of responsibility for habitat restoration and groundwater management. It's essential for these reasons to continue to grow and diversify our science and technology partnerships as we continue in our mission for sustainable water management. To help us do this, we developed an inventory and dashboard to help us track, communicate, and promote our science partnerships, as well as expand our network. So we're excited to share highlights from that inventory. It's a dynamic dashboard. A still shot is shown here. Presently, we've inventoried 81 partnerships spanning engagement with 14 different divisions and offices at the department, 11 organization types, and representative of $77.9 million of financial investments, as well as in-kind partnership support. These partnerships span 33 science fields, with many in aquatic ecology, fisheries biology, hydrology, as well as data science and social sciences like environmental policy. These partnerships are diverse in the types of activities that undergo, from scientific research, emerging technologies, incorporation of indigenous knowledge, science education, and more. These partnerships, as I mentioned, are not only partnerships driven by financial investments, but also in-kind support, such as advisory committee engagement from DWR technical staff. I'm going to highlight a few of our partnerships in the inventory for you now, and as you've heard and you'll continue to hear, there are several more partnerships that will be represented at the symposium. Many of our partnerships are interdisciplinary and multi-partnered in nature. This one here is a multi-partnered partnership with many academic institutions listed here, and is a project to explore reintroducing cultural fire to manage DWR wetlands, to explore carbon and habitat impacts during and after burns. As you can see, many science fields are representative, many are partnership types, and Tyler Anthony, who's here, is DWR's lead for this partnership effort. An example of our science education partnership work is this longstanding partnership with the Water Education Foundation that provides Project Wet climate change workshops for K-12 educators. These are workshops where science educators are provided hands-on science-based water resources and climate change materials to take back to their students. As a result, over 248,000 students have benefited from science-based water and climate science lessons. And Jordi Vasquez and Emily Alejandrino are DWR's leads for this partnership work. The final highlight I'll have for you is an emerging technology and data science partnership. This is with the Office of Data Innovation, or ODI, and is an effort to develop an app for rapidly screening continuous water quality data with steering and support from DWR technical staff. The data science advancements from this project are a model for more efficient treatment and sharing of quality data across many programs, and will contribute to saving staff time for more timely posting of QC data. Ted Swift and John Franco Saraceno are the partnership leads for this effort. We're continuing to use the dashboard to track and communicate our existing science partnership work, and as well as promote opportunities to explore new partnerships. We're working toward a public dashboard to put on this DWR Science webpage, a page we're looking to update and enhance with other resources for science partnership. So I'd encourage you to continue to connect with us, to explore new partnership work, and connect with me or Luis if you'd like to learn more about the dashboard. Thank you.
Thank you, Lindsay. All right, next up, Kevin He.
All right. Okay. Good morning, everyone. My name is Kevin He with DWR Modeling Support Office. Today, I'm going to talk about machine learning-based data salinity emulated dashboard. My talk has two parts. First, I'll provide some background on why data salinity is important, and what factors drive it, and how we track or predict it. And next, I will provide an overview of the dashboard. Oops. Okay. All right, so starting from why data salinity matters, it doesn't just affect our drinking water quality. It also impacts our agricultural, ecological, and industrial water uses. And because of that, understanding and predicting data salinity is critical for many aspects of our water management. So what factors drive data salinity? First, environmental factors such as precipitation, stream flow, wind, tides, and many others. And second, water management factors, including regulations, operations, diversions, barriers, and gates. And there are also other factors, such as bathymetry change, restoration projects, in-delta discharges, and others. So with so many factors at play, how can we know salinity levels across the delta? So there are two main approaches. First, we can monitor salinity directly using sensors at selected locations. And second, we can use numerical models. And one such model is called Data Simulation Model 2, or DSM-2. Our DWR Operations and Maintenance Division uses DSM-2 to forecast data salinity to inform their operations. We also use DSM-2 in many of our planning studies, such as the Data Conveyance Project. And other state and federal agencies, consultants, and interested parties, they also use DSM-2. And our office has been maintaining the model ever since it was first developed about, I would say, 35 years ago. However, there are a few challenges with DSM-2. First, it doesn't have a user interface. Second, it takes time to run the model. For example, for 1 year of simulation, it can take 5 to 10 minutes. And third, model accuracy, it can vary depending on the locations and conditions. So to address these challenges, our office and UC Davis developed a machine learning-based dashboard to emulate DSM-2. The overarching goal was really to take advantage of the big amount of data available in the delta, plus the advances in data science and machine learning, to better estimate data salinity in a much faster way to inform our operations. And the dashboard can be accessed by scanning the QR code here. It was built with a very simple architecture. So all the machine learning models are trained using Google Colab. The trained model input data and dashboard scripts are all saved in GitHub. And the dashboard is hosted on Microsoft Azure. And here is what the dashboard looks like. Using the dashboard is very straightforward. It only has 4 steps. First, select the year you are interested in. Second, you can select an input. You can play with the input. Specifically, you can choose input, and you can scale them up and down by using the slider. And both the modified and original time input will be displayed in the time series plot here. And third, you can select the location you want results for. And finally, click compute. So in just a few seconds, the results will be generated and displayed in the bottom half of the dashboard. Here is an example output for Edmonton, which is a compliance location. And here the black line represents the DSM-2 simulations, green, that's the machine learning results, and red, that's the observations. And you can zoom in, zoom out, you can check specific values for any specific date, and you can also select different machine learning models, and you can download the input or output data. To wrap up, I want to share the QR code for the dashboard again, and also a QR code for hands-on training with more detailed guidance on how to use the dashboard, and also a few peer-reviewed journal articles on how the dashboard was developed. I also put my contact here in case you have any questions. That concludes my presentation. Thank you for your time.
Thank you, Kevin. All right, our next lightning talk speaker is Daphne Gill.
Hello, everyone. My name is Daphne Gill. I'm an environmental program manager in the Division of Integrated Science and Engineering. And today I'll be telling you a little bit about our genetic monitoring program that I co-lead with Melinda Barrowald, who is also here. All right. The DWR Genetic Monitoring Program, or GEM, was launched in 2022, mainly because of the following oops, didn't advance. Oops, there we go. Okay. Because of the following catalysts. First, our division was giving new mandates from the California Department of Fish and Wildlife Incidental Take Permit and the Fish and Wildlife Service Biological Opinion for long-term monitoring of the State Water Project. And these mandates require or greatly benefit from genetic approaches. And additionally, genetic monitoring offers efficiency and flexibility that may not be possible with traditional methods. And we can make management decisions faster and perform work in-house and reduce piecemeal contracting costs. Additionally, we can embrace new technologies, which is a mainstay of our DWR strategic plan. And so today, after several years of hard work, we have a fully functional genetic laboratory in our office in West Sacramento, and many of our staff members perform genetic work as part of their job duties. And so the GEM program is currently State Water Project funded, which means that most of our work is related to the operation of the State Water Project, but we hope in the future to have the program be available to all of DWR. And then one of our most important monitoring projects is the identification of Chinook salmon run type at our DWR fish protective facilities for real-time operational decision-making. And we must accurately measure the number of winter-run Chinook salmon salvaged at water export facilities to remain compliant with our federal and state permits for continued operation of the State Water Project. And historically, Run ID was performed using a length-of-date model, but we know that this model is highly inaccurate. And so genetic methods are currently our best chance for accuracy. And so now at the fish protective facilities, what happens is there's an initial determination of winter run that is made via the length-of-date model. And then at that moment, we have 72 hours to then overturn the run determination using genetics. And so one innovative rapid method that we use to do this is called Sherlock, which is a DWR and UC Davis collaboration. And so if the length-of-date run determination was not overturned, water exports may be reduced to help protect endangered species that may become entrained. And if the fish is not a winter run, then exports continue as they were. And in the last 2 years, genetics has overturned about 95% of the winter run length-of-date determinations, meaning that the vast majority of the times the water exports did not need to be reduced, but could have been if genetics hadn't overturned the run designation. And currently, each incorrect decision based upon the length-of-date assignment could cost California about 15,000 acre-feet of water, which is enough to supply 15,000 to 30,000 families with water for 1 year. So as you can see, a lot rests on these results of even a single fish, and we need to be sure we've got it right so that we can supply California with the water it needs, while also ensuring protection of listed species. And then another problem that we've been able to address with genetics is improving larval smelt entrainment monitoring using environmental DNA, or eDNA, tools. Specifically, delta and longfin smelt are two listed species that can become entrained in water export facilities, which affects water exports. Oh, there we go. And currently, only smelt that are more than 20 millimeters are quantified at fish protective facilities, and there is concern that smelt take may therefore be underestimated. And as part of our permits for long-term operation of the State Water Project, DWR is mandated to initiate a longfin smelt science program and investigate ways to quantify smelt entrainment. And so eDNA is the DNA that organisms leave behind in their environment. This can be in many forms. It can be skin, scales, waste, and we can detect that using genetic assays. And let's see, in this case, the sensitivity of our eDNA methods is attractive because we need to detect very small rare fish species that are difficult to capture using physical methods. So if you see up in the top of the photo here, there are 300 larvae in that one single tube. So we're talking about the earliest life stage, the smallest size and rare species that you can get. And so for this study, we deployed cages containing known varying numbers of smelt larvae near water export facilities and collected eDNA samples downstream from the cages using several eDNA sample collection methods and at multiple distances. And what we found was that we were able to reliably detect a larval smelt at an abundance of 300 using multiple eDNA detection methods. And in some cases, we were able to detect down to one larva. And again, here's a light table with some larvae on it just to remind you how very, very small what we're trying to detect is. And so additionally, we found that using a common tow net to collect eDNA samples was the most sensitive method, which is foundational to using eDNA for monitoring of listed fish species in the future. And so in summary, with this study, we can use genetic tools to monitor a rare species at an early life stage that may not be possible with traditional methods. And in closing, I just want to thank our phenomenal team whose names are listed here, and in addition to our collaborators at UC Davis, the Department of Fish and Wildlife, and Kramer Fish Sciences. Thanks for your attention.
All right. Great job, Daphne. All right, our next speaker is Tyler Anthony. Over to you, Tyler.
Yep, good morning, everyone. My name is Tyler Anthony. I'm DWR's Carbon Sequestration Specialist, sitting in the Land Stewardship section of the Division of Multi-Benefit Initiatives with Molly Farrell. And really want to talk to you a little bit today about science-based land stewardship for carbon and climate benefits. And so just taking a step back, the Land Stewardship Program is really a coordinated effort across DWR to ensure that we're adaptively managing DWR lands, both to maintain and enhance ecosystem resilience, but also ensure that we have proper coordination to meet both DWR's and state climate and water goals. And so really what land stewardship is adaptive management in action. And so we take these science-guided restoration approaches via these sustained research partnerships. We heard a little bit about that in Lindsay's talk, what we're trying to implement on the ground. But really this looks like long-term ecosystem monitoring and research to ensure that we're meeting our sustainable outcomes for our ecosystem restoration projects, but also it helps us identify potential co-benefits that we might not have thought of during the initial planning phases of these projects. And it's also a useful tool for ensuring that ongoing management and investment can help us reduce the long-term costs of maintaining these ecosystems and really ensuring that they meet the goals that we designed and implemented them for. And so often land stewardship looks like really hands-on, on-the-ground actions, but we wanted to take a kind of a larger, different scale approach to give an example here today. And so the Sacramento-San Joaquin Delta is a great example of why stewardship is needed. And so it's arguably one of California's most important water sources. It's a central hub for both this State Water Project and the Central Valley Project. Through agricultural drainage of these peat soils, much of it has actually subsided more than 30 feet below sea level since the 1800s. And so this is subsidence that's still happening, and actually because these are peat soils, or organic matter-rich soils, they're also a significant source of greenhouse gases, and so these are some of the highest emitting ecosystems on Earth. And so another reason why this is unsustainable from a water resources perspective is that a major levee breach would disrupt freshwater delivery. The amount of land subsidence in this region causes a large amount of accommodation space for saltwater intrusion if there were systematic levee failures across the delta, and this could disrupt our water supply anywhere from months to years, depending on when this occurs. And this continued subsidence increases pressure on our levees and increases this risk of catastrophic failure. Additionally, not only is this contributing to climate change is also making this worse. And so sea level rise is increasing the water level on one side of the levees, while subsidence is decreasing the land elevation on the other side, just stressing an already fragile ecosystem and water delivery system. And so really, why does this matter to water resources? The status quo is unsustainable. Even with climate resilience projects like the Delta Conveyance Project, still 80% of SWP water in 2070 needs to be conveyed through our current delta ecosystems. And so really, we can't maintain the status quo with continued subsidence and continuing rates of sea level rise. We also need to make sure that we're taking advantage of one of the highest quality climate solutions we have on this planet. So we know that these drained peat soils are some of the highest emitting ecosystems on Earth, but wetland restoration is actually, in this region, is one of the most important climate solutions we have because it sequesters carbon at some of the highest rates on Earth. You can see that in one of the posters we have in the poster session later this afternoon. And so really we need to take advantage of these climate solutions and maximize our ability both to adapt to climate change but also mitigate climate change. And I'm way under time, but thank you very much. Yeah.
Great. Thank you, Tyler. All right. Next up, Ted Flynn.
Hi, everybody. My name is Ted. I am the lead for the environmental monitoring program here at DWR, which is one of our longest running monitoring programs in the Delta. And I'm here to talk about kind of beyond open data. I think a lot of us have heard that term referring to the scientific data that we collect, open data, open publications, open access. And I think that there's a lot to more than just making our data open so that we can make our data as useful as possible. So a little bit of background about the environmental monitoring program and kind of our collaborator program. So EMP is a long-running biological and water quality monitoring program. It's been active since 1975. But it encompasses a lot more than kind of what's traditionally been called EMP and really expands to include all of our D1641 compliance monitoring. So this is the monitoring that's in D1641 that says, okay, if you're going to be operating these projects, DWR and the Bureau of Reclamation need to operate this specific monitoring program, and it's such a large program, it involves multiple groups. My group, Morgan Batty's Continuous Water Quality group, but also Steve San Julian and Jared Francich and others, including our federal partners with the Bureau of Reclamation and USGS. So there's a huge number of these stations here, and we collect thousands and thousands of data points annually, right? I did just a quick back of the envelope. It looks like we collect right about 1,600 biological samples. We collect around 12,000 discrete water quality measurements. And then, of course, with our real-time water quality, which is collecting every 15 minutes, we make over 300,000 individual measurements every year. That's a lot of data, and there's a lot of time and effort that's spent collecting that, and a lot of resources put into making sure that we have that data year in, year out. And this guides our water product operations and provides an incredibly important environmental baseline in the Delta. So, we know about things like AB 1755, all this data must be made publicly available, but there's a big difference between, uploading an Excel spreadsheet to a website and saying, hey, our data is publicly available, go ahead, have fun, and really making that data accessible. And so there's kind of a framework called FAIR data, and there's a lot of publications on there, kind of one of the original ones I have referenced down there if you want to look at it, but FAIR stands for findable, accessible, interoperable, and reusable. So open data is really focused on availability, right? It's the data's here, go ahead, have fun. So an example of that would be you take your Excel file, put it on Water Data Library, and you say, download it whenever you want. FAIR data, it's a lot more involved. There's a lot more work that goes into making that data not only online, in repositories and other things, but that it can be used by other scientists. It can be used by people outside of DWR. It can be used by people outside of the United States who are studying, maybe studying estuaries. Maybe they're studying climate change. It could be all of these different things. This data that we collect can be so much more important the more people who are able able to use it. And so an example, say, of fair data would be taking that same water quality data, but putting it in a machine-readable format with rich metadata that describes how that data was collected, what type of instruments were used, how were they calibrated, and then putting that in an index repository instead of just kind of a local website that maybe you only could find if you know exactly what you're looking for, where something like the Environmental Data Initiative has data from researchers from all over the world. So why should we do this? Why should we follow this? You know, data is useless without context, right? Transparency is essential to building the public trust for a program like ours, and I think the numbers kind of speak for itself. Since 2020, since the Environmental Monitoring Program started posting this type of data on EDI, it's been downloaded over 23,000 times. That's a huge number. That's a lot of people, and it's not just people in California, it's not just people in the Delta. Since that same time, we've had about 16, it's more than 16. 16 was my kind of rough count, but I know there's more out there, peer-reviewed publications that have used our data. And these aren't necessarily DWR authors. These are other folks who find our data useful and use it to write papers. It also saves staff time. Instead of every time we get a data request, staff have to scramble to get it for them, we just say, go on EDI, it's right there, read the metadata. We also have a website, and I'm running out of time. This is our website. I've got a QR code if you want to look at it. But even beyond the data, we publish all of our annual reports here. And not only that, we publish all the code that we use to make those reports. So it's kind of a more comprehensive way of looking at it. So thanks, everyone. It's a huge team that makes it happen. I appreciate your time.
Thank you, Ted. Right on time, so perfect. All right, our next speaker is Stephen Springhorn.
All right, good morning, everyone. Just wanted to acknowledge the large team that's working across the department, other state agencies, federal agencies, and institutions that have come together to work on this topic that I'll be talking today. But a lot of information has been flying out at you, so I'd like us to take a moment, a groundwater moment of sorts. I want you to look down at your feet by your bag and water bottle. And no, there's no gift. This isn't sponsored by Oprah, but there's something more important behind or beneath this stylish carpet. Beneath the concrete is a groundwater basin. It's our home groundwater basin. It's the South American groundwater basin that if you live in this area, that's your groundwater basin. And the other 514 groundwater basins across the state are very important for California water, and in any given year make up 40% of the water supply across the entire state, and that goes up to almost 60% in droughts. So if you get one thing out of this 5 minutes, groundwater is important, and we're doing everything we can to learn more about it. So we want to try and go from these fuzzy, artistic-styled versions of the subsurface to things that are more data-driven, that can get fed into models and inform management decisions. And so we're increasing our knowledge of the subsurface across the state at about 60 miles per hour as fast as this helicopter is flying. And so why are we doing this? We're doing this because the water code requires us to do this, and there's a giant need, as I mentioned. But DWR has been doing this for decades, and so we're really standing on the shoulders of many geologists at the department and other agencies across many decades, and we're having to work at even a faster pace now because the decisions that are in front of all of us are much greater and have substantial consequence. We're also trying to maximize the use of our natural infrastructure, right? These groundwater basins have been deposited over geologic time. So Daphne talked about eDNA. Think of this as the geoDNA of the subsurface, and we need to understand it so then it can be utilized to its fullest extent in a sustainable way. And just not bragging at the groundwater side of things, but it does make up the lowest cost, largest form of storage in California. So there's a lot of opportunity there. So how are we doing this? We're starting with very key objectives in that trying to inform groundwater management. So that's subsidence, recharge, understanding the three-dimensional texture of the aquifer. We're doing it with a community of practice and trying to build that up so we can share information across the department and other agencies and institutions. So we start with an enhanced data collection. We do that by space, air, and land. We've been doing a lot of that, as you'll see. We then make sure that data is accessible and usable, and you can see it at low to no cost. Then we put all that into stewarded maps and models that can be utilized to then go into decision support frameworks. We iterate on that as we collect more information, and then we archive it as we go. So this is the incredible team that's been brought together here. It's international in nature, lots of expertise here, and it's really awesome that we have a great cross-section across the department, different divisions, from state agencies, federal agencies, again, international consultants and support. So we're all trying to answer this question, what lies beneath? So if we look at 60 miles across our favorite estuary and Sacramento Valley, about 8,000 feet in depth, what we see is a lot of question marks and dashed lines, meaning uncertainty. So the time is up for having this much uncertainty beneath our feet because, again, the decisions are so important. So what we're doing is we're trying to fill in the gaps of the known place. So if, doctor analogy, if you only know what's going on with your health in one spot of your body, that's not very good. So what we're doing is we're filling in the gap. So think of this as an MRI for the subsurface. So we can see a lot more continuity, structure, and we can start to pick out the gravels of the Feather River. We can start to see where the recharge areas are. We can start to see where those recharge areas are connected to the principal aquifers and maybe where we want to stay away from brackish groundwater, and so on and so forth. So we're in an era of aquifer characterization, and we need to be doing even more. And what has been done even more is bringing new technology and higher resolution to probably arguably the best characterized piece of the Delta is Prospect Island. So shout out to North Central Region Office. We brought for the first time ever in California FLOTEM, so pulling some little rubber rafts with high-end geophysical instrumentation, filling in the gap of that surface groundwater interaction, pairing that with ground-based surveys to then get unprecedented detail on continuity of surface and groundwater, which it is all connected. So with that, here's the framework with data sources, open data, viewers to inform decision-making so we can have this be repeatable, standardized, and then used. So with that, thank you, and look forward to answering any questions and working with you all going forward.
Thank you, Stephen. All right, next up, second to last is Heather Shannon.
All right, thank you. Stephen's always a tough act to follow. So my name is Heather Shannon. I'm a supervising engineering geologist in DWR's Sustainable Groundwater Management Office. And today, the topic of my talk is the Subsidence Information Campaign, Socializing Scientific Information. So today I'll talk to you about the impetus for us initiating this effort and also a partnership we developed along the way. So many of you in the room that are working in the water resources field are most likely familiar with the Sustainable Groundwater Management Act, or SGMA. So I won't dive into the details of that today, but one thing I wanted to highlight is that land subsidence is one of the 6 sustainability indicators that is identified in SGMA and that groundwater sustainability agencies are required to manage. Another item to flag is that the legislative intent of SGMA states that, that we should avoid or minimize subsidence. For those that are not familiar with land subsidence, simply stated, this is the sinking of the land's surface. I wanted to draw your attention to the center of the screen. This image shows the cumulative subsidence that has occurred between June 2015 and January 2024. Although you can't see the scale here, the maroon or darkish red color indicates that over 4 feet of subsidence has occurred in these locations during that time frame. So over the past 10 years since SGMA passed, we've continued to see subsidence. So in an effort to support groundwater sustainability agencies in either communicating with their interested parties or in developing management strategies to avoid or minimize subsidence, the department initiated 2 efforts, the education campaign and the development of the best management practices. I won't be talking about the best management practices today, but I'll just say that the 2 efforts have been complementary, and the teams have been working together. So early in the education campaign, the department corresponded with the Harrison-Galveston Subsidence District in Texas to understand their process they had gone through in educating their communities about land subsidence. The department was able to draw from materials they had presented to their community that were successful tools in communicating these complex scientific concepts. And the outcome of this partnership and collaboration resulted in the production of videos and other fact sheets that the department is using to communicate with groundwater sustainability agencies and also interested parties. And then I will also highlight that as part of this education campaign, DWR outreach specialists, communication specialists, engineers, and scientists all have collaborated as part of this partnership. So as I mentioned, the education campaign uses multiple tools, including our website, videos, fact sheets, social media posts, and other technical materials that we've developed for practitioners as they're proceeding forward with developing their management strategies. I wanted to highlight that this effort is still ongoing. We recently had our 3 public meetings for the draft best management practice, and we gathered public comments on that document in addition to meeting with the community and gathering information about what they might find useful to further understand the topic of subsidence. And I will just say that we're continuing to develop materials alongside with the development of the best management practice document, and at the bottom right is a new fact sheet that we'll be releasing very soon. If you're interested in checking out any of these materials, here's a couple QR codes you can access to look at the information. Our subsidence website will continue to be updated with information and ways to access future fact sheets, information, et cetera, data. Finally, I'll leave you on a light note. Our DWR social media team put together a series of posters as a nod to the Emmys and those nominees. And so instead of Severance, they selected Subsidence, featuring my colleague down here that you just heard from. So with that, thank you.
Thank you, Heather. All right. And that takes us to our last lightning talk presenter. So over to you, Stanley Mubako.
Greetings, folks. My name is Stanley Mubako from DWR's Land Use Program. Our objective, or our goal, rather, in the land use program is to survey land use frequently and efficiently using technologies that include remote sensing, geographic information systems, GIS, and field observations. So the tool we are focusing today is what we have termed or coined the DWR Land Use Gallery. So what is it? In short, it is a collection of ArcGIS web applications. And it serves the purpose of sharing information and providing it to our end users. We have a bunch of status dashboards. It is a form of a land use data inventory. There's also a timeline of the DWR land use program for those who are interested in our history. And of course, also land use data downloads. The QR code is there. You can sample it during your own leisure. So what sort of partnership is responsible for producing this data set? We have at headquarters here the land use unit, mainly responsible for coordination as well as the quality assurance process, QA/QC. And we collaborate widely with our regions in the department, from the north all the way to the south. And our regional offices are mainly responsible for QAQC as well as collecting ground reference data or ground truthing. Lastly, we do collaborate with consultants, LandIQ LLC, and they are responsible for implementing our land use mapping workflow. A little bit of a teaser in terms of the data, the outputs that we produce. 9.6 million acres of statewide irrigated acres on average. And for that period, since 2014, we've accumulated over 3.3 million. That is the number of fields that we've mapped statewide. I will leave you folks to digest the rest of the statistics. So what are the benefits and outcomes from this partnership and through the implementation of these technologies? As you can see here, the idea is not for you to read through everything, but just take a look in terms of what we do. There's the California Water Plan, Crop Consumptive Use Estimates, Sustainable Groundwater Management Act. Most of the presentations that have happened today, I can assure you, they are consuming land use data in one form or the other, be it Sigma or some form of modeling efforts that are going on throughout the state. And what sort of decisions are being made that are science-driven? A lot of them, through the use of land use data. This is just an overview of some of our end users, the institutions who are consuming land use data, starting with our department, California Department of Water Resources, and it goes even beyond. So the long and short of this is that everybody loves and they need land use data. If you're not sure about why you need land use data for what you do, please come and talk to me afterwards, and I'll give you the story. So at this point, I would like to invite you folks, through that QR code, to sample our land use gallery. And in terms of the technology, as we've discussed, it's basically a collection of ArcGIS web apps. On the top left is our homepage. It's basically based on ArcGIS story maps. And on the right, that Survey Explorer, you can also download some of the data. It's based on ArcGIS instant apps in terms of the technology. On the bottom left, we have a dashboard that is sort of real time. As our regions collect ground reference data, it updates real time. It's based on ArcGIS dashboards. And lastly, on the right, there's an app that is based on Experience Builder or Web Experience. And through this app, we can take a look at some of our layers, as well as click on links that will take you to the Open Data Portal for downloading the data. This is our contact information. That's the Land Use Unit team. And I want to end by acknowledging all our collaborators, our management for all their unwavering support through this effort. And of course, the conference organizers for inviting us to tell the land use program for the department in 300 seconds. Thank you very much.
Well, thank you to all the session 2 speakers. If you haven't done a 5-minute lightning talk, it's definitely a challenge to keep to 5 minutes, but everybody did great. So thanks to the session 2 speakers for being great on the time. So that takes us to the Q&A portion for session 2. So thank you for folks who submitted questions using this QR code. You can still submit your questions using the QR code on the screen or in your programs. Just getting to the first question, so this one is for Stephen. So in areas between AEM scans, is there an extrapolation method used to predict underground conditions based on spatial patterns?
All right, great question. Yes, there's a model that goes into making that MRI type image. So we take the known points of the borehole data, so what the sands and gravels are. Then we also, the helicopter, as it's flying along at 60 miles per hour, it's taking depth soundings. So those are sort of pseudo points every few meters, it's going down. So all of those are points at a known X, Y, and Z, and all of that is put in together to then do some, it's a form of a model of the subsurface lithology, so you can see what might be more fine-grained, what might be coarser grained. So it gives you a lot more information, but then as a geologist, we're always looking for more, so we try and stack up different water quality information and other core samples if you got it. So it is definitely combining as much information as you can will give you the best result in that.
And Stephen, maybe you can keep the mic. There's a couple more questions that I see that folks were having for you, so you can knock those out. So your next one was, how often does DWR map groundwater levels?
Oh, groundwater levels. So I wish I could tell you that it was higher frequency than we do right now, but it's a wide variety. So I would encourage you to take a look at our semi-annual groundwater conditions reports. So our team in our North Central Region Office leads that effort with other region offices, and they have a whole section dedicated on what the groundwater monitoring network looks like across the state, how it's measured and monitored. So at DWR, we have anything from semi-annual measurements at the least frequent to real-time telemetered stations, which is rapidly increasing by a lot of hard work by the region offices and headquarters partnership. So we now have over 230 real-time groundwater monitoring stations, and that's really exciting because we're going to try and ramp that way up as much as we can. And then we work with a collection of local agencies that collect their information and submit it to us. So think of it as like the groundwater version of the snow cooperative surveys. So we're trying to build that across California.
All right, one more question for you while you have the mic. Are there any real-time telemetered groundwater gauges or measures?
Yes, so I just mentioned that. It makes up 3%. So the fall semi-annual conditions report will be coming out next month, so take a look at that. But in that report, it shows that the little slice of pie, it started at 0%, and now it's at 3% of real-time groundwater monitoring data. So we're going to continue to ramp that up because that's the type of information that we need to inform decisions that are happening, like Heather mentioned on subsidence, or different impacts that we're seeing, dry wells, for instance. So the more that we have higher frequency data, the more that we can inform decision making or be proactive versus reactive in the groundwater space. But we have a long way to go on that.
All right, thank you, Stephen. All right, the next question is for Kevin. How does the salinity emulator compare to the current ANN used to run long-term CalSim scenarios?
All right, so the first difference is the architecture. So the ANN model currently in use with CalSim. That was architecture developed about middle 1990s, about 30 years ago. It was the best architecture back then. So currently, the machine learning model I talked about this morning was using the more recent architecture, so it's more kind of in the deep learning area. So that's a difference in the architecture. Number two is the training method. So the model used in the CalSim, it only trained using one scenario. And the model I talked about earlier today was trained using multiple different scenarios. So basically, we run the DSM2 model under different conditions. We scale up the input up to 20%. We kind of scale down the input also down to 20%. So think about the historical condition. For example, for the extreme drought or wet years, we scale them up or down 20 years. So not kind of expand the conditions. So the machine learning model, they are kind of exposed to more extreme conditions. So the model trained in this way are more, I would say, more resilient. So it will be able to kind of apply it to unseen conditions in the history. So it can be probably applied in climate change scenarios, for example. So that's the second difference. And the third difference is the, I would say, philosophy. So the current model in CalSim, you have to develop one model for one compliance location, Edmonton, Jersey Point, and other locations. So you have to train and develop a separate model for each separate location. So the models I talked about earlier today, we can use one model for all the locations in the delta due to the complexity in the model structure or model architecture. So there are other differences, and definitely if you guys are interested, send me an email. We can definitely talk more on that offline.
All right, thank you, Kevin. Next question is for Lindsay. right. How did you collect and input the data for partnership dashboard? How have you identified an ideal strategy for this going forward?
All right, great question. And I couldn't cover this in the talk. All of the data inputs were self-reported data from a number of DWR technical staff from outreach with various science and engineering teams that are interdivisional in nature, that focus on environmental coordination and climate change issues. But certainly, I'm going to make a plug for anyone at DWR that's involved in a science partnership to please reach out to me to add to the inventory as we move towards a public dashboard. We are using Microsoft tools for form entry into a list to develop that Power BI dashboard. We're moving towards a public version to post on the website. We know that there are more partnerships out there that you'll hear about as well. So we're planning an annual refresh through some automated processes with those Microsoft tools available. So that's the general strategy moving forward, but certainly connect with me if you'd like to engage and learn more.
All right, thanks, Lindsay. The next question's for Tyler over on the other side of the, oh, to your right, so Brian. Thanks, Tyler. All right, the question is, what are the efforts being made or planned to monitor ongoing subsidence in the Delta? Any comment on DWR's effort to identify vulnerable levees?
Yeah, so what I failed to mention is actually that a lot of our wetland restoration projects in the Delta are actually for subsidence reversal, so that was kind of an important point I might have missed in the talk. So we only know that those wetlands can actually reverse subsidence because of our ongoing partnerships and measurements and continued measurements, and so we're trying to leverage just some internal efforts to monitor that more cheaply because land stewardship is something that doesn't have a lot of funding towards it currently, ongoing monitoring efforts. But in the past, we know there are many efforts like satellite imagery. I think INSAR is a good example there that we'd like to potentially take more advantage of in the future. But we really need better on-the-ground truth and measurements to really coordinate with that to make it more effective, especially in places with the Delta with lots of vegetation and varying water table levels and all of that. And really, I think identifying subsidence and impacts on Delta levees, there's whole branches of like the Division of Multi-Benefit Initiatives and across DWR that are working on that. But I am not directly involved with that research. I do have a bit of a carbon bias.
Thank you, Tyler. Next question is for Daphne. So Daphne, how do you tell if eDNA is from living larval smelt versus dead ones?
Yeah, that's a really great question. It's one we get asked frequently when people are thinking about do I trust eDNA, how do I interpret the data? And the answer really is that you can't tell the difference if you have eDNA data or eDNA a detection from a living or dead organism. However, that doesn't really concern us because of two things. So the first is that we have several years of foundational eDNA collection data that tells us that in our very turbid estuary with fast-moving water, the eDNA signals really don't stick around for a long time. We're talking on the order of 1 to 2 hours. And so it's whether or not we're picking up a dead organism or one that is alive, we just don't think the eDNA signal is going to hang out for a long time. Additionally, we have some pilot efforts to evaluate eRNA, so environmental RNA. So RNA is a different kind of molecule. It's only shed from living organisms, and it's present in the environment for a much shorter amount of time, even less than in 1 to 2 hours, because it's less stable and it breaks down so quickly. And so we're evaluating methods to detect eRNA in addition to eDNA, so we have both metrics. But yeah, we have, like I said, we have several years of foundational work in this field, and so we feel really confident that for the most part that we're detecting live organisms.
Maybe there's one more question for you.
Okay.
For the genetic testing of fish, is everything done manually? Is it any part of the fish identification automated?
Okay, that's a good question too. So in our genetics lab, so I guess there's two ways I could potentially interpret this question. In our genetic lab, we have a lot of instruments and equipment that allows us to have really high throughput and really scale up. So we have liquid handling robots where we can process thousands of samples at a time, and additionally, whenever we do sequencing, we have instruments that also sequence dozens to hundreds of samples at a time. So yes, we do have the ability to scale up and be automated. Additionally, when you say something is manual, everything's really done manually, and that you really do need a person to to do the work. Something else I wanted to mention is that, and Melinda's here, this is really her program, but bringing genetics to salvage. So we will be able to do genetic testing at salvage. That's something that's being piloted this year. So we take our portable genetic instruments to location. They can also be brought to the field to do some of these genetic tests. So yes, everything done manually with the help of instruments, and yes, we can scale up.
All right. Thank you, Daphne. All right, for Jamie, how can we support or get involved with the 5th assessment?
If you just Google California 5th Climate Change Assessment, they have a website and you can sign up for the newsletter there, and then you'll receive information when opportunities do come along. This assessment is fairly far along, so they've recruited a lot of the peer reviewers and things already. And we're quite a ways through our process of writing our internal report. We did outreach at several different groups, trying to recruit information, but that was a year ago or so. But please sign up for that newsletter, and that's where you'll find out things that are coming up, and I imagine that list will roll over into the next assessment, because these are done as soon as one finishes, then the process for the next one begins, because they come out every 5 years. So, but if you have something you'd like to contribute that maybe we haven't put in the report, it is still in the draft stage. You can send me an email, jamie.anderson@water.ca.gov.
All right, thank you, Jamie. And the next question is for Ted. So the question is, what are the implications of AI for fair data?
Okay, this is a great plug for the upcoming IEP workshop in the spring. We're going to be talking a lot about AI at the IEP workshop, so everybody mark your calendars. It's going to be awesome. Second of all, I think that's a really big question, and I think Rosie, is Rosie here? Rosie and I were joking yesterday that one or both of us needs a sign in our office that says, read the metadata, because so many of the questions that we get about our data, it's documented in the metadata, but a lot of times, especially if you think of a monitoring program like EMP, where we have 50 years worth of data, that's a lot of metadata, right? There's a lot of detail that went into describing, okay, well, from this year, we use this method, but from this year to this year, we use a slightly different method, but then we went back to the old method, but then we went back to a different, right? Those types of things. So Gen AI could be really, really good at scanning a 100-page document full of water quality protocols to find the one you're looking for. That could be a really great thing. So things like that could be really helpful. But also, if you're talking about using AI to process data sets, right? There are things you can do to kind of fill in the gaps, right? We all have missing data. Maybe you couldn't go out a certain month. Maybe your sensor was broken. And you can there are tons of statistical models out there that will allow you to interpolate missing data. But if you just put it in there and publish the data set, you don't say that, well, actually, we used a generative AI model to create that, and you don't say what statistical model you use, and people just start using the data without knowing any of that, that's a huge problem. And the more people start doing that, some of these databases that we have might start having unreliable types of data in them, and we might, there's a lot of stuff just kind of generally conversations about AI, right? A lot of, if you play with it on your phone like I do, Google, I know now, if you use Gemini, it will actually create a little AI watermark on the photo, right? So you know that that photo was AI generated. It's also in the file metadata that's attached to that photo, right? So we're gonna have to develop protocols for our own data when it involves AI on some level. I also wanted to just, it's kind of just the tip of the iceberg, but there's a lot there. And then I would also just, there's another part of FAIR that I didn't mention, it's called CARE, C-A-R-E, the FAIR CARE principles, and that a lot of it, I don't exactly remember the C-A-R, a lot of it has to do with working with indigenous data and data collected by indigenous peoples. It's really, really important, it's fascinating. I would go to the NCEAS website at UC Santa Barbara, NCEAS, they have a lot of information about it. But the E stands for ethics, right? The ethical use of data and having an existing framework of how we can ethically not just use data, but how we can ethically publish and create data sets. And I think how we use AI when we're doing that is going to be just becoming more and more important as the months and years go by.
All right, Thank you, Ted. All right, I think we might have time for one more quick question for Kevin. Can the water quality tool forecast water quality? What inputs are required, i.e. what flows need to be forecasted? If you could, in a couple of minutes.
Yeah, so currently the model that I talked about, it can only forecast the salinity because it was trained using salinity data only. And the goal was to emulate DSM-2 in salinity simulation in the data. And all the input required for the machine learning is identical to the input required for the DSM-2 model. We do have machine learning model for other water quality variables. We have, so if you guys are interested, we can definitely talk more on that offline.
All right. Thank you, Kevin. All right. Well, that takes us to the end of session 2. Let's give the session 2 speakers a round of applause. Great job, everyone.